In this video, I'm going to talk about graphing rational functions with linear numerator and denominator. A rational function is a function where both the numerator and the denominator are polynomials. In this video, I'm going to focus on both the numerator and denominator being linear polynomials. In other words, they will be always of the form ax plus b over cx plus d. In order to graph such a rational function, we first need to know the graph of y equals to 1 over x. The graph of y equals to 1 over x is given by a hyperbola. The hyperbola of y equals to 1 over x looks like the following. It has two branches. When x is positive, then we have the graph that curves like this. When x is negative, then we have a similar curve in the third quadrant. It is very easy to remember this graph. When x is big, then 1 over x is the reciprocal of a big number, so the output y value will be very small. When x is very small, like 0.1, then 1 over 0.1 will be 10, and so the output y value will be relatively big. When x is negative, then 1 over x is also negative, and therefore we have a similar curve in the third quadrant. It is important to realize that if we perform a horizontal stretch or shrink on this graph, the characteristic shape will not change. And by the characteristic shape, we mean that both the x-axis and the y-axis are asymptotes. Asymptote is referring to a straight line such that your graph is approaching this straight line indefinitely, but not overlapping. We can easily see that the asymptotes are not affected by horizontal or vertical stretch or shrink. For example, if you want to graph y equals to 2 over x, then this is performing a vertical stretch by a factor of 2. And what we do is to measure the vertical distance from the graph to the x-axis and double it. By connecting all the dots, we will see that the graph would look like this. Similar thing happens for the other branch. And you can see that the new curve is still approaching the x-axis and y-axis indefinitely. Because of this, when we graph the rational function ax plus b over cx plus d, then we focus only on asymptotes and reflection. To do that, we first perform a long division of the numerator divided by the denominator. For example, if we want to graph y equals to 7x minus 3 over 4x plus 5, then long division says that we should put the numerator inside the long division symbol and the denominator outside. What should we put in the quotient? It turns out that we have to perfectly match the 7x. And in order to do that, we have to put 7 over 4. So that 7 over 4 times 4x will have the 4 cancelled, and we get 7x in this position. 7 over 4 times 5 will be positive 35 over 4. And we do a subtraction between these two. 7x minus 7x is gone. Negative 3 minus 35 over 4 is negative 12 over 4 minus 35 over 4, which is negative 47 over 4. This finishes the long division with quotient 7 over 4 and remainder negative 47 over 4. In the next step, we will write the rational function in the following form, where the quotient goes here and the remainder goes here. So we have y equals to 7 over 4 plus negative 47 over 4 divided by 4x plus 5. In the third step, we try to study the position of the vertical asymptotes by using the domain of this function, analyze the position of the horizontal asymptotes by using the vertical shift, and by using the sign of x, we will study whether there is a reflection or not. In this function, there's only one x in the denominator. So in order for the function to be well defined, we have to make sure that 4x plus 5 is non-zero. In other words, the domain of this function have to avoid negative 5 over 4. Hence, the vertical asymptote of the graph of this rational function should be at x equal to negative 5 over 4, so that there is no chance for our input to hit this number. Next, when we look at this rational function again, we can see that this portion gives some vertical stretch, horizontal shrink, and horizontal shift. This is indicating the vertical shift. Hence, our horizontal asymptote is shifted up by 7 over 4 units. Recall that our original horizontal asymptote is the x-axis. So the new horizontal asymptote is at y equals 7 over 4. Normally, we will graph our hyperbola in this region and this region. However, if we look at this rational function, we see that there's a negative sign in the numerator and a positive sign in front of x in the denominator, which means that there's one reflection in this process. Hence, we'll graph our hyperbola in this region and this region instead. If there are negative signs in both the numerator and in front of x in the denominator, then there's a vertical reflection and a horizontal reflection. As a result, the hyperbola will go back to the traditional position, meaning that we should have our hyperbola in these two regions. This completes our discussion of graphing rational functions. Thank you for watching this video. If you like it, please subscribe to our channel, and we will learn more fun math together. Thank you.